Welcome on this tutorial. Wish all you are well. Here I am going to discuss about the different documents and different diagrams which are very much important for a student as well as for an engineer who are working in the field. These diagrams and documents are important for instrumentation engineer as well as process or chemical engineer, electronics engineer and electrical engineer. Different documents are instrument index. This instrument index having list of instrument with tag number and other informations. Instrument data sheet. This is having specification and other information of a particular instrument. Cable schedule. This describes the different lengths, type and size, color, termination details, route, conduit details. Bill of materials, which is a complete list of all the items that are required to build a product. I will discuss about these different documents in details in a separate tutorial. Now, the different drawings which are very much important are block flow diagram, process flow diagram, piping and instrument diagram, loop diagram, summer diagram, hookup drawing or diagram, JP and instrumentation location drawing. To work in the field means in the process plant, an engineer must know about these different types of drawings. P&ID diagram, this is process and instrumentation diagram. It is also called piping and instrumentation diagram. This P&ID diagram and loop diagram are most important for the whole life of plant, from starting to design, erection and commissioning, startup, operation, maintenance, and also for any type of modification. To get the knowledge about those diagrams, an engineer must know about instrument and process equipment symbols, instrumentation identification tags. The documents and drawings are important because they are used to communicate the technical details of a project in a common format. The drawings also become the foundation of future project and cost saving for customers. I'll try to discuss features of different diagrams. This block flow diagram. This diagram expresses a particular operation of a plant. The operation is like that. There is a reactor. Toluene and hydrogen are entered into this reactor to produce benzene and methane. The reaction does not go to the completion and excess toluene is required. The non-condensable gases are separated and discharged. The benzene product and the unreacted toluene are then separated by the distillation column. The toluene is then recycled back to the reactor and the benzene is removed from the product. So this is the operation. Now this operation is described here by the block only. This is one block, there is another block, there is another block. So what are the features of this block flow diagram? The block or rectangles used to represent operation of a full unit. Unit operations such as mixers, separators, reactors, distillation columns and heat exchangers are usually denoted by a simple block or rectangle. The blocks are connected by a straight line which represents the process flow streams. The process flow streams may be mixture of liquids, gases and solid flowing through the pipes or ducts. Process flow streams flowing into and out of the blocks are represented by neatly drawing straight lines. These straight lines should normally either horizontal or vertical. The direction of flow of each of the process flow stream must be clearly indicated by arrow symbol. The flow streams should be numbered sequentially or identified. Say this is the toluene, this is effluent, this is benzene, like this. Unit operations, that is blocks, should always be labeled. This block is labeled with reactor, this is gas separator, this is distillation column. Where possible, the diagram should be arranged so that the process material flows from left to right with upstream unit on the left and downstream unit on the right. So this is block flow diagram. So the block flow always indicates the whole process or part of the process by using the different blocks. Next, process flow diagram. Process flow diagram, also known as process flow chart, process flow sheet, process flow scheme, system flow diagram. Process flow diagram is the best document to develop more complex P&I diagram. What is PFD or process flow diagram? Process flow diagram is a simple drawing that shows relationship between major components. Relationship between major components in a process plant using equipment symbols and shows the primary process flow path of a unit. We can visualize the flow of material within the plant with the help of those drawings. To show the practical process example with process flow diagram, let's examine 3 diagrams here for a compressor control system. In this fictitious process, water is being evaporated from a process solution under partial vacuum. The compressor transports the vapor to a knockout drum where some of them condensed into the liquid form. Now this process is described here by using the process flow diagram. Here the total process is described by using the main components. Which are the main component? Evaporator, compressor, knockout drums, and as well as little about the different control valves and other accessories. So the purpose of the process flow diagram is merely to show the general flow of the process itself, and it shows a very minimum of control instrumentation. May say here how this control valve is controlled or which are the related instruments connected with this control valve not indicated here. Similarly for this control valve. Or for the case of compressor, what are the different control systems are used, this is not indicated here. I am taking another example here describing what are the different informations provided by process flow diagram. Process flow diagram provides all major equipments. Here it indicates the major equipments. Which are the major equipments? This is one distillation column, this is another distillation column, this is one pump, this is reboiler, this is reflex drum, this is one control valve. These are the main parts indicated by the process flow diagram. Next, process flow diagram shows all the flow streams. Here the flow stream is gas, here the flow stream is named as sweat gas, here this is makeup water, this is rich amine. Process flow diagram indicates flow direction also. Say this is coming from here to this direction and the flow direction is indicated by the arrow symbol. This is coming here, the flow direction is indicated by the arrow symbol. It shows the major control valves and process critical valves. There is one major control valve, there is one major control valve. So many other control valves are also used here that is not indicated here. The process flow diagram shows the major bypass and recirculation system. Say here, this is the recirculation system. The process flow diagram shows the different connections with other systems also. What are the parameters or what are the features which are not included into the process flow diagram? Process flow diagram never shows the pipe classes and pipeline numbers. Means which type of pipe has been used or what are the numbers of the pipes. It never shows the process control instrument. Process control instrumentation means the controller and the measuring instrument. Those are not included or not shown in process flow diagram. Minor bypass valves are not included in the process flow diagram. Isolation or shut-off valves are not included. The maintenance vent or drains, these are not also shown in process flow diagram. Now where we will get these informations? We will get this information in process and instrumentation diagram. To know the process and instrumentation diagram, we need to know various symbols for equipment, valves and other instrument also. Now entering into the process and instrumentation diagram. Process and instrumentation diagram, also known as piping and instrument diagram or PEFS, which is process engineering flow scheme. Process and instrumentation diagram is a schematic representation of pipelines, vessels, control valves, instrumentation and other process component and equipment in the control system found in process environment such as oil refineries, chemical plants, paper mills, cement plant, etc. PFD shows the major interconnections of the process vessels and equipment but omits details such as instrument signal lines and auxiliary instruments. It is a complex than PFD. A single PFD can have multiple P&ID. This means if some system is shown on a single PFD, to show the same system on P&ID, it may require multiple P&ID sheet. This is the process flow diagram. I have already used this diagram while I was explaining process flow diagram. Same example of process I am using here to explain the process and instrumentation diagram. So this is process or instrumentation diagram. No control system was explained here. Means what are the different control systems related with the compressor, it was not explained here. But in the case of process and instrumentation diagram, this is just like a zooming of this part. All the control systems have been described. In this PFD, only one transmitter was indicated here. FT is the flow transmitter. Nothing more have been indicated in PFD. In the case of process and instrumentation diagram, we can see here FIC42. This is flow indicating controller. This controller gets two signals. One signal from this flow transmitter. This is the symbol of Venturi, flow meter. This flow transmitter gives flow signal to the flow controller. And the signal is coming from this pressure differential transmitter. This pressure differential transmitter, differential pressure means pressure difference between these 2 points. This signal is the differential pressure signal. This is one input. Flow transmitter signal, flow signal is another input. According to these two signal, this controller is giving a particular signal to the control valve, which is ultimately controlling the recirculation of this flow. This recirculation path flow is controlled by this control valve. So here in the compressor, what are the different control systems are there, it is indicated in the process and instrumentation diagram or piping and instrumentation diagram. But in PFD, it was totally absent. Similarly, if we zoom in this part, we will get similar type of control operations also. Also, we will get the similar type of control operation in this case also. So, what is the difference between PFD and P&ID? For the case of PFD, only the main equipments or main process is indicated and very small numbers of instruments or control valves are there. But in the case of piping and instrumentation diagram, every control instruments, every measuring instruments, every valve, these are indicated in the piping and instrumentation diagram. Here we can also see that two temperature transmitters are here. This is TT43, this is TT41. And signal from this transmitter is going to the temperature indicating recorder. Means it indicate the temperature as well as the record the temperature. To know the PFD as well as to know the P&ID, an engineer or a student must know the different symbols of different equipments and the different piping systems also. I will discuss elaborately regarding the different symbols in another tutorial. Here I am giving another example. Say this is the piping and instrumentation diagram of heat exchanger. This is the heat exchanger, this is the control valve. Steam enters into the heat exchanger. This is a particular fluid having low temperature. Because of the presence of steam, this fluid is getting heated and ultimately a heated product is at the output. This is the normal process. How this process is controlled, that is explained in this P&I diagram. What is happening here? The temperature of this heat exchanger is measured by this temperature transmitter 401. The temperature signal is the input of this controller, temperature indicator controller. According to this signal, this gives a particular signal. This dotted line indicates this is the electrical signal. This electrical signal goes to a converter. TY401 is the converter. Now this converter means in this case this is I2P converter. This converts the electrical signal into the pneumatic signal. This signal ultimately controls or ultimately operates this control valve which controls the flow of the steam line. So this is the diagram. So when the engineer will ultimately implement this into the process will look like this. Say this is the heat exchanger system. This is the temperature transmitter, maybe thermocouple RTD. This temperature transmitter signal goes to the controller. This is the controller. Controller gives the signal to I2P converter. Controller gives the signal to I2P converter. I2P converter gives the signal to control valve. This is the control valve and this is the steam flow in, steam flow out. This is the cold water, cold out. So before the implementation, this type of drawing is done. This drawing is used while the process is implemented, as well as at the time of maintenance, as well as the different trainings for the engineers and operators also. This is another P&I diagram of reactor control. So this is the reactor. What is happening here? This is the flow transmitter. This flow transmitter gives the signal to the flow indicating controller. Another signal is coming from here, temperature signal from this temperature transmitter 1 to 3. This is the temperature indicator or temperature controller. This gives the signal to here. So this is one signal, this is another signal. Ultimately, according to these two signal, this controller gives an output. This output through this I2P converter ultimately controls this control valve. Here this is a motor operated control valve. This is the PLC symbol. So PLC ultimately controls this motor operated valve. So what I am explaining, an engineer must know this. What he should know? That this is the PLC. He should know this is the temperature indicator controller. This is the temperature transmitter. Like this. One number is given here, 1 to 3, 1 to 3, 1 to 3, 1 to 3. Everywhere is given 1 to 3. This numbers indicates that all instruments or controllers, this are related with a particular operation or with a particular control loop. So this is process and instrumentation diagram or piping and instrumentation diagram. Now what are the different features not included in the P&ID? P&ID never tell anything about process condition and physical data. Process condition and physical data means it never indicate what are the value of temperature, what are the value of flow or pressure like that. It never indicate the operating condition, say under which condition the operation is going on. It never indicates stream flow details. Stream flow details means, say this is the steam in, but what is the flow rate of this steam, how much is the temperature of this steam is not indicated in P&I diagram. This P&I diagram never indicate the equipment location. Equipment location means the exact location of the instrument or equipment in the process. This is not indicated in P&I diagram. Next, pipe routing, length and fittings. These are not mentioned in the P&I diagram. Pipe routing means from where to where the pipe has been installed, means exact location. The length of the pipe between two instrument or two equipment, and also the different fitting which are required to install the different instrument and also pipes. These type of features are not mentioned in the P&I diagram. Support and structural detail means an instrument or a control valve, how it is mechanically installed or inside the plant. It is not indicated in the P&I diagram. A P&ID diagram never shows what are the types of the cable used for connecting the different instrument, wire numbers, terminal blocks. These are not mentioned in the piping and instrument diagram. So process flow diagram gives an overview idea of the process using the different major equipments. Piping and instrument diagram gives the more details, more instrument, more control operations are included in the piping and instrument diagram. If we want to know or examine this type of different levels, we must go to the loop diagram. I will explain loop diagram and other important diagrams in a separate tutorial.